Welcome everyone, hope you're doing well. We're still in our systems unit, even though before this we just took our systems test. This just isn't gonna be on the test, but it is gonna be on, we're gonna just have like a skill check over it, something smaller. So this is linear and nonlinear systems, all right? And we're gonna make this real easy for you guys, okay? So there's a lot of different ways this could look, because nonlinear could mean many different things. We're gonna focus on only a few, okay? So far all we've been doing are linear equations, but you could have like a system where one is linear but one is a quadratic. So if you remember, like a quadratic is a U, right? So if you think about if that's one of our graphs and then we also had a line, right? This would have two intersection points. So we got one right there and one right there. And absolute value works the same way. So if you remember absolute value, that's a V. All right, same deal. You could have, a line going through that with two intersection points. So linear, nonlinear systems, they have a, 2, 1, or no solution. So no infinite solutions here, right? It's either not ever, or sorry, yeah. So quadratics, if you want one solution, it's kind of tricky, but you got to draw your U, and then you got to have your line. It's got to just like barely go by it like this, okay? So you've got only one intersection point. It just, I like to say high fives it as it keeps going. And then you've also got your no solutions. Now this is easier to have than it was before. Before you had to have two parallel lines. Here, you simply just need to have lines that go like underneath the U, right? And that would be no solutions. And all the V's work the same way. So the main way that we're gonna do this, okay, is we're gonna use Desmos. Because, we taught you guys how to graph quadratics, but that was a whole thing. Oh, sorry. That was to solve a bet before. It was a whole thing. Could you graph the quadratic by hand? Yeah, you could. If we look at these, we've got y equals 3x and y equals x squared plus 2. You could hopefully graph both of those if it came down to it. Y equals 3x, that's a line through the origin with a slope of 3. Okay, so we can make that line. Right, so y equals 3x, you can see, there you go. Up 3 over 1, up 3 over 1. And then y equals x squared plus 2, well, you should know that's a u up 2. So we'd be going up 2, and then you go over 1 like that, and then over another and up 4. So it actually hits both those points right there. So here's our U. Not the best U, but you can see that here are the two intersection points right there. All right. And now if you type that in, y equals x squared plus 2. It's exactly how ours looks, right? Where are the two intersection points? At 1, 3, and at 2, 6. So this is two solutions. All right. We've got 1, 3, and we've got 2, 6. So this might be an easier way to get solutions. Actually, we're not going to do that. We're going to say x equals 1 and x equals 3. Now, that might be easier for you than solving it algebraically. We're going to solve one algebraically real quick just to remind you how to do it. Remember, if you have a quadratic, the way to solve that, we have a bunch of different solving methods. You could solve by completing the square. You could solve by the quadratic formula. You can solve by factoring. Either way, remember, you want to get everything onto the same side. We could solve this by factoring. What multiplies to make 2 and adds to make negative 3. Negative 2 and negative 1. Is this correct? So we get x equals 2 and x equals 1. Oh, I actually wrote down the wrong thing before. This should be x equals 2. Yeah, x equals 2 is what we got. So you can see, you could solve it by factoring, but you could also solve it this way. We're going to give you some things. Basically, we want you to try and solve this by just using Desmos, right? Can you graph it, and can you plot, find the intersection points and graph these? Now, the x minus 2, the linear ones, I hope you guys can graph those. I mean, x minus 2, that's just a slope of 1, right? With a y-intercept at negative 2. Right, so I mean, there's our line right there. And then we've got our second one. The quadratics, maybe you want to use Desmos more, especially when it's one like that where you'd have to complete the square in order to graph it, or go through the whole process of finding the vertex. But using Desmos, it can graph it for you. So we found our vertex is at 2, negative 6. And then, you can look for other points, but, if you remember, all right, when it has an a value of 1, it goes up 1 on either side. And then if you go over another one, it goes up 4. So we've got 1 right there, and we've got 1 right there. So this one, it actually looks like intersects right there at 0, negative 2. And then there's another intersection point up there at 5, 3. So that's this point right here. So that means there's got to be another point right there, if you remember the axis of symmetry. So we can drop this down. Here's our 2 intersection points, one at x equals 0 and one at x equals 5. Okay, and so that's pretty much what you're doing. I mean, you could graph anything, right? We can make the graph look whatever we want. So like here, we've got negative 1/2 x as one line, and then the other line we have absolute value of x plus 3. And, where are 2 intersection points? Negative 2 and negative 6. X equals negative 2. X equals negative 6. So the question is, can you get this accurately onto your graph? I mean, you should. All right, you should be able to. X equals negative 2, 1. We know that's an intersection point. And negative 6, 3. We know that's an intersection point. So can you graph this line? Yeah. And then can you graph the V? Well, where's the V's important point? Negative 3, 0. And then it looks like, it just has a slope of 1. So we know that we're going to be going like this on one side. And on the other side, we're going to be going like that. And so there's our 2 intersection points. All right. So hopefully this isn't too much for you guys. We're just going to practice using Desmos to solve these systems, right, rather than solving them ourselves. So If you want to, finish this, try a couple more, you can. Tomorrow, your assignment is to do the practice. If you have any questions, let me know, and have a great day.